Hello and welcome everyone. I'm here to present my research topic of manufactured fine sand, which was undertaken as part of my research studies for a master's program in pavement technology. So in this presentation, we will be discussing why this topic was undertaken, what is manufactured fine sand, a detailed petrographic study, the production process of manufactured fine sand, production analysis, properties of manufactured fine sand, a discussion on the experimental program, the effects of particle shape, and a literature review on skid resistance. So why manufactured fine sand? Now when we think world shortage, the first thing that comes to our mind is water and natural gas, right? However, there is a not so obvious shortage at hand, and yes, that's natural sand. Now when we picture sand on a beach or endless deserts, we probably think of it as an infinite resource. But because we use sand for constructing almost everything, it's beginning to cause all sorts of problems. Now we need to keep in mind that not all sand that we see is suitable for construction, as its properties can substantially reduce the strength of concrete. Cities and urban areas are expanding at a very fast pace. Now that mainly involves construction of buildings and streets, and that's where sand comes in. It is an essential ingredient for concrete, asphalt, and production of glass. Study shows that even silicon chips used in electronic devices are made with sand. The demand for sand will only increase in the years to come. So the question we need to ask the industry is the replenishment rate high enough to meet this growing demand? The second reason for looking at manufactured fine sand is the environmental legislation. Extracting sand from sources such as rivers and sea flow will damage the ecosystem and their ability to function. Hence, we have mining leases and regulations which confine and control the extraction limit. The New South Wales or any state government will take immediate action for non-compliance and could also involve a loss of license. Another important thing is logistics and cost. Most of the sand pits are away from cities, which increase the transportation cost. Hence, it was necessary to look into a fine sand alternate. What is manufactured fine sand? Manufactured fine sand is defined as a purpose-made aggregate produced from a suitable rock source. In quarries, when the rock is crushed and sized, the main aim is generally to produce coarse aggregates and roadways. This process usually produces a byproduct which is less than 4.75 mm in size and is commonly known as crusher dust. Now the quality of crusher dust totally depends on the crusher and the rock properties. Most of the quarrying companies have made significant progress in producing a manufactured sand. However, there is little to no research on manufactured fine sand. When I first thought about this project, the biggest question was, where do I start? So I consulted our production team at Dunmore and DSS Quarry, and they advised we should be speaking with our end users. So after consultation with our concrete technical team, it was agreed that the final fine aggregate blend will need to be similar to our current mix, which is a combination of Peppertree coarse sand and DSS fine sand. The whole intention of this project is to reduce the use of natural fine sand and increase the use of manufactured fine aggregate by 90%. Now before any production, it was necessary to confirm that the source material complies with Australian Standards 2758.1 2014 aggregate and rock for engineering purpose. A detailed petrographic study was conducted on washed crusher dust to determine the rock suitability. So from the study, the rock was described as latite, consists of 91% primary and 9% secondary minerals. The aggregate was summarized as non-porous and unweathered. It presents low risk to alkali-silica reactivity. The rock poses a low risk for use as fine aggregate in concrete, unbound pavements and asphalt aggregate, and an overall low risk for durability, strength, hardness, sulfides, light particles, aggregate polishing and voids. So based on petrographic study, the rock was deemed suitable for the production of manufactured fine sand. Production of manufactured fine sand. So as we can see in these pictures, the production involves a two-stage process. Stage 1 is getting rid of the oversize, and stage 2 is getting rid of material passing 75 micron. So manufactured fine sand is produced by screening crusher dust over a 2.2 mm inclined wet screen, which separates the oversize and washes the 75 micron component. This process is carried out at Dunmore Sand and Soils, which is equipped with a wash plant to wash natural fine sand. Now, as we know, the particle size distribution plays a very important role in the final performance of concrete. Production was carried out in 3 different runs, and below is a comparison for particle size distribution. These results give us confidence in producing a very consistent product. After producing a consistent product, the next challenge was to produce a blend of fine sand, manufactured fine sand and preparatory sand to replicate the customer's current combined fine sand grading. As we can see in the last 2 columns of this table, blending 3 different sands at agreed ratio, a combined grading almost similar to the current mix was achieved. After consultation with the concrete technical team over minor deviations in the grading, like the one on the 600 micron, which is 49% and 57%, from experience it was agreed that this minor outlier would not cause any major issues. Properties of manufactured fine sand. As we all know, aggregate size and gradation are the most important factors in selection of concrete aggregates. A well-graded material will consist of particles that are fairly evenly spanned from fine to coarse, whereas a poorly graded aggregate leaves large voids in concrete, which in turn will require excessive amount of cement paste to fill voids, making the mix uneconomical. As discussed earlier in this presentation, manufactured fine sand grading was found to be satisfactory. When manufactured fine sand is produced from durable rock, there is a good possibility that the 75 micron will consist of fine rock powder and little deleterious fines. Now, when referring to AS2758, the 75 micron limit can be misleading, as this mainly applies to natural sands in order to control silt and clay, which can increase the water demand and cause shrinkage and cracking. To investigate these 2 levels of fines, we tested the product for 75 micron and 2 micron in accordance with AS 1141.12 and AS 1141.13. A total of 4% passing 75 micron and 0.1% passing 2 micron was achieved in the manufactured fine sand. In a study conducted by a PhD student in 2012, it was noted that 75 micron fines from manufactured sand may act as a filler and also improve the workability of the mix. Uncompacted and compacted bulk density. These values are usually used to control volume batching. An uncompacted bulk density of 1.45 ton per meter cube was achieved for both fine sand and manufactured fine sand. The manufactured fine sand also achieved a compacted bulk density of 1.56 ton per meter cube, which is above the minimum limit of 1.2 ton per meter cube as nominated in Australian standards. Particle density and water absorption. Proper control of water is always important for a good concrete mix. Water absorption totally depends on the aggregate properties and the surrounding liquid. If dosed correctly, this will help the hydration process in the cement to incorporate mechanical strength. A particle density of 2.55 ton per meter cube was achieved for the manufactured fine sand, and it meets the minimum limit of 2.1 ton per meter cube as per Australian standards 2758. A water absorption of 1.6 was achieved, which is below the limit of 2% as per the Australian standards. Voids content. This test is commonly used to measure shape and surface texture of any fine aggregate. The flow time is directly proportional to the grading, shape and texture of the manufactured fine sand particles. The less time to empty the cone, the better the shape and surface texture, which means better workability. Straight fine sand usually has good flow properties, but this also means high water demand. Usually, if the fine aggregate fails to pass through the cone, this is referred to as coarse and poorly shaped aggregate with high void content. In order to overcome this issue, manufactured fine sand will be blended with natural fine sand. Clays in manufactured fine sand. One of the basic parameters of any aggregate is their cleanliness from clay. These clays usually attract moisture and can cause swelling or shrinkage, which can lead to cracking. In order to study the type of clays, the following tests were conducted. The first one was the sand equivalent test in accordance to AS 1289.3.7.1. The objective of this test is to quickly evaluate the proportion of clay in any fine aggregate. A low value of sand equivalent describes the sand as dirty. A sand equivalent of 84 was achieved for the manufactured fine sand. The second test conducted was the methylene blue test in accordance to RMS T659. This test, commonly known as the MBV, is used to determine if clays that are present are active or harmful. An MBV of 3 milligrams was achieved, which was pretty low for the manufactured fine sand. So now we go to the experimental program. We conducted two mixes of 40 MPa. Mix 1 was with straight DSS natural fine sand, and mix 2 was a blend of manufactured fine sand and fine sand at a ratio of 70-30. As we can see, we used 250 kilos of fine sand per meter cube in mix 1 and 175 kilos of MFS along with 75 kilos of fine sand in mix 2. So when you look at it in terms of percentage, mix 1 had 100% of DSS fine sand and mix 2 had a combination of MFS and DSS fine sand at a ratio of 70-30. Now we are looking at our 7-day compressive strengths. The gray bar represents the strength for concrete made with natural sand, and the blue bar represents strength of concrete made with manufactured fine sand. Now as we can see, for the same amount of water cement ratio, manufactured fine sand has demonstrated a slightly low strength as compared to the concrete made with natural fine sand. As I mentioned in my report, the particle size, texture and grading could have direct impact on fresh and hardened concrete properties. Concrete mixes containing high amount of poorly shaped particles tend to require high amount of paste to achieve good workability. There is also a good possibility that the other properties such as air content, bleeding and segregation might be affected by the use of manufactured fine sand. So this is 28 and 56 day compressive strength results presented in the form of a bar graph. The gray bar represents a concrete mix produced by natural fine sand, and the blue bar represents a mix produced by manufactured fine sand. Now you can see a similar trend in our 28-day results. There's a difference of approximately 3 MPa between both the mixes. At 56 day, it seems to be closing the strength gap, which is a good thing. So that's the 7-day flex strength tested on concrete beams. Not a massive difference. As mentioned in my report, angular aggregate particles can actually help improve flex strengths, and we can actually see the results in this graph here. So here are the flex strengths at 28 days. Again, not a huge difference, an average loss of around half MPa. So this is the average standard drying shrinkage graph. As we know, concrete will resist shrinkage due to the restraining effect of aggregate particles. We hardly see any difference between both the mixes. At 7, 14, 21, 28 and 56 day, the shrinkage is similar in both the mixes. This also gives us assurance that the manufactured fine sand is free of organics, deleterious fines or harmful clays. Effects of particle shape on concrete mixes. Now the shape of the manufactured fine sand mainly depends on the type of crusher, the type of rock and the quantity of rock fed into the crusher. As it can be seen in the picture, the manufactured fine sand is observed to be angular, and the use of a vertical shaft impactor in the crushing circuit could potentially produce more rounded particles. However, research also shows that flex strength of concrete can benefit from the angularity of crushed particles due to an improved bond and aggregate interlock in comparison to natural sand. An economical way of improving particle shape is by blending a higher percentage of natural fine sand with rounded particles. A literature review on skid resistance using manufactured sand in pavements. Now, skidding or sliding can occur due to lack of friction between two objects. Friction is usually created between the tire and the pavement, which allows the vehicle to move, stop and turn. Now, during lab trials, it was understood that the inherent qualities of concrete aggregates is responsible to create a highly skid resistance pavement, as this improves the micro texture. Contribution of aggregate towards surface texture. Now, micro and macro texture are the two important properties of a pavement surface. Micro texture is mainly influenced by the fine aggregate and is important to maintain enough friction at speeds under 72 km per hour in both wet and dry conditions. A well-graded fine aggregate will not only influence the friction but will also reduce noise, splash, rolling resistance, tire wear and damage. It is understood that manufactured fine sand will improve the micro texture, thus increasing friction between the vehicle and the pavement. Limitations on current research. In the study presented, only one standard mix with a target water cement ratio of 0.41 was used. We know from practical experience that final concrete performance is directly related to the choice of cement, admixtures, and the combination of coarse and fine aggregates. Hence, the results and conclusion presented are only valid for the mix design used in this study. The study has provided ideas and improvement on the production of manufactured fine sand. Grading results conclude that a consistent product can be produced using the current production technique. Also, the lab concrete trials have determined that conforming concrete can be produced using a higher percentage of manufactured fine sand. As discussed earlier, an average of 5% strength drop was observed between parallel tests using natural fine sand and manufactured fine sand. Manufactured fine sand can be used in concrete pavements to provide a good skid resistance. As discussed, the particle shape of the manufactured fine sand plays a very important role in the performance of a concrete mix. Further evaluation is needed to incorporate a vertical shaft impactor, commonly known as a VSI, in the crushing circuit. A VSI is usually added as a supplementary machine with cone crushers, as it can generate excellent particle shape. The disadvantages of a VSI include a higher generation of undesirable fines and lower product yield. The excess fines should not be an issue, as the manufactured fine sand is washed prior to stockpiling. Risk management. The current research has been based on a 70-30 mix of manufactured fine sand and natural fine sand. In order to avoid any mix complication, a trial of 30 manufactured fine sand and 70 natural sand would be beneficial. If you have any questions, please feel free to send me an email. Thank you.